Today we're going to be multiplying and dividing rational expressions. We are not going to really learn anything new today. We're going to put together a lot of things that we've learned before, and jointly they'll look like something new, but it's not. And let's start off with something simple that I think we all know and understand. We have a 25 here and a 9 there. We can't do anything except that, remember, in an earlier lesson we were kind of cross-dividing and cross-multiplying and things like that. So that if this is connected, that's not a plus sign or a minus sign, that's a times sign, that all of this is connected. So 25 over 55 gives us 5 over 11. And the next thing I should be moving to is the 24, because I said we factor numbers first, right? Well, I'm going to make an exception, and this is why. If I start jumping around like this, I'm going to forget what I did and what I didn't do, and I might leave something unreduced. So something that I could have factored down or reduced down or simplified, and I didn't do it. So I'm going to just start at the beginning and just work my way this way. And so x squared, I don't have an x squared down here, but I have a x to the 7 here. Okay, well, what's 7 minus 2? That's going to be x to the 5, and where is my x to the 5th going to be? It's going to be with the bigger exponent. There we go, x to the 5th. And now our next one is going to be 24, and the 24 is not going to go into 11. No common factors there. 24 and 9, we have a common factor of 3, and we have 8 and 3. And then our last factor is y to the 4th. And let's see, we have y to the 8th here. There's no y here. And so 8 minus 4 is going to be y to the 4th. And where is it going to be? Let me give you a hint. Where is it going to be? It's going to be down here with the bigger exponent. And that is reduced as much as we can reduce it. And as an extra check, I like to go through the top again and make sure I didn't miss anything. So 5, no. 8, no, nothing is divisible. And so now we can just multiply this out. 5 times 8 is 40, and 3 times 11 is 33, and there are no x's to multiply, and there's no y's to multiply, so it's just going to be x to the 5th times y to the 4th. Now let's do that with division. Okay, we've done this before, and if you remember, when we're dividing two fractions, we take the second fraction and we flip it. And then we follow through just like we did last time. Let's see, we have a to the 4, and we have an 1a down here. We don't have any more a's, so that's the only a we have down there. So 4 minus 1. 4 minus 1 is 3. Going from a to b squared over b to the 4th. 4 minus 2 is b squared. And it's going to be down here because that's the bigger exponent down here. That takes care of that. And 4, there's nothing to divide down here or factor down here. And so let's just multiply all this out. And it will be 4a cubed over b squared. And let's run through this again. No 4's, no a's. We're good. Okay, that's the final answer. Okay, now we're going to try the same thing with polynomials. Well, as bad as all this looks, it's really nothing new. It's just a combination of things that we've learned before, and we're going to put them all together today. And we're just going to start with two fractions. I understand that they're kind of complicated fractions. But let's put that together again down here. And if you remember, a long time ago we learned that before you multiply you need to reduce. And before we reduce, sometimes we need to factor. So let's start with our first term up here. What does that look like? X squared minus 9. Well, by now you better see that that's the difference of squares. Remember I had you memorize all those squares? Remember 1, 4, 9, 16 on up? And you memorized them, didn't you? Oh, I'm sure you did. Anyways, that's a square and that's a square. 9 is one of the squares. They're separated by a negative sign. That is the difference of squares. So why don't we break that apart just like we have before? There you go. That wasn't too bad. And let's go to the denominator. And first thing we're going to have to do is tear that 20 apart. Let's do that. Okay, and we're trying to add or subtract to get to 1. 1 and 20 is not going to do it. 2 and 10 is not going to do it. 4 minus 5 or 5 minus 4 will get us to 1. So let's put that in there. Okay, those are the numbers we need. And what are the signs we need? Let's see. Our 20 has a negative sign and we have a positive 1. So it's going to be 5 minus 4 is positive 1. Okay, our next polynomial is the numerator in the next fraction. So let's tear apart that 16. Can we add or subtract to get to 8? Now let's see, 1 and 16 is not going to do it. 2 and 8 is not going to do it. 4 and 4 will get us to 8. And we got a positive 16, so both of them will be positive or both of them will be negative. Let's see, we're trying to get to negative 8. So how about negative 4 and negative 4 gets us to negative 8? Oh, that looks real good. So let's get to the denominator into the second fraction. And what are we going to have? Let's tear that apart. Well, wait a second. We have a coefficient in front of the first x, and it is in order. So what's going on there? Well, we can't factor out a negative. We can't factor out, oh yeah, we can. We can factor out a number. I can factor out a 3 out of that and a 3 out of that. There we go. And that makes sense. You're not going to be factoring binomials out of a binomial unless it's the difference of squares, which that certainly is not. And guess what? We've done all of the hard work. Now we're going to cross divide. We're going to look in our numerator starting right here, x plus 3, and on the bottom we're going to look for another x plus 3. Let's see, there we go. So I can cross out this x plus 3 and that x plus 3. Now normally I'm just going to erase these, but just so you can see what we're doing, this time I'm going to cross them out. And at the risk of repeating myself for the 50th time, x plus 3 over x plus 3 is 1. And anytime we reduce any fraction to 1, we can eliminate it. Well, I shouldn't say any time, because you've seen that there are circumstances where sometimes we need 1 as a placeholder. But since we're going to be multiplying this 1 times several other things, we don't need a placeholder. And so let's see, x minus 3. Now we're going to start here. We're going to work our way all the way straight across. If you see stuff that we can eliminate, just hold your horses, okay? We're going to do this methodically. I know when I was your age, I would just start crossing stuff out and then you miss stuff. So let's do it very methodically. X minus 3. No. 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 And so what else do we have? X minus 4. No. Ooh, yeah, we do. And of course, x minus 4 over x minus 4 is 1, so we can eliminate those. And we have one more x minus 4. No. No. And so that's it. We have eliminated everything that we can eliminate. Now, everything that we've eliminated, I should say everything that we've crossed out, I am going to erase. Now you should be bringing it down to right here on your paper. but I'm just going to erase it. And there you go. We're just going to multiply everything out, and we're going to have x minus 3 times x minus 4, and we're going to have 3 times x plus 5. Let's move all that over here. And that's the answer. That's what that will look like. With one other thing I should tell you. You don't have to multiply out the denominator, but sometimes you have to multiply out the numerator. We're not going to right now because we don't have to. Actually, it's fine either way. You can multiply it out or not multiply it out. However, if you still have work to do, you're going to want to multiply that out. We might have something over here that we need to add to this over here, okay? And so to add it, we're going to have to multiply it out to add it. Otherwise, we're going to be really messed up. But our work is done, so let's move on to the next problem. Now this is the same kind of problem, except it's division. But we already know that division is the same thing as multiplication, except what? We're going to flip this fraction and multiply. Now, I know there's a lot more stuff to flip here, but that shouldn't be too hard. Why don't you flip that? Good, and we're going to factor the numerator in the first fraction, and we've already torn apart this 12. So let's see. We're going to get to 1. How do we get to 1? Can we add or subtract this to get to 1? No, no, yes. We can subtract 4 and 3 to get to 1. So let's put that together. And we have a negative 12, so that's a subtraction problem trying to get to negative 1. Let's say 4 minus 3 is not negative 1. 3 minus 4 is 3, negative 4. Okay, let's move to the denominator. And we're going to tear apart our 8, which I already have. And we need to get to 2. And I cannot add or subtract this to get to 2. 4, 2, yeah, I can. And of course, negative 8 is a subtraction problem, and I'm trying to get to negative 2. Let's see, 4 minus 2 is positive 2. That's no good. 2 minus 4. So 2, negative 4. Moving to the numerator in the second fraction, I have a 2. I don't need to tear that apart because there's only one possibility, and that's 1 and 2. That looks good, and I think I've explained this before, but sometimes I put the smaller number first. Sometimes I put the smaller number first. Sometimes I put the bigger number first. It doesn't matter. For what we're doing, it's not going to matter. So if you see me going back and forth and wondering what in the world I'm doing, it just doesn't matter. But anyways, we have a negative 2, and so that's a subtraction problem. And we're trying to get to positive 1. Okay, so 2 minus 1, 2 negative 1 gets us to positive 1. So let's put that negative 1 there. Okay, moving to the denominator of the second fraction. I have a coefficient in front of my x squared. So let's see, can I factor a 5 out of 5 and 15? I sure can. And let's see, sign, number, variable. Let's do our variables next. Do I have a variable? We have a common variable. Let's factor an x out of there. And after I factor 5x out of this, I have x plus 3. Okay, and so that's completely factored out. Let's see if we can start eliminating anything. Let's start at the top, start at the numerator, start way over on the left-hand side. And we have x plus 3. Now let's come downstairs and see if there's an x plus 3 to factor out. No, 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 yes. Good. And remember, I told you I wasn't going to cross them out anymore. I was just going to start erasing. I may cross them out if it's convenient for me. But anyways, we have x minus 4. Let's come downstairs. No, yes. Good, now we have x plus 2 as we're moving from left to right. X plus 2, let's eliminate those. And that, my friends, is your answer, except you might want to get rid of that multiplication dot. And that's still a little sloppy. Why don't you move that x minus 1 over here? And you're not multiplying x minus 1 times anything, so you can get rid of those parentheses. There you go, and that's our solution. And one other thing I want to mention, I've mentioned this many times before, but do not cancel these x's out. That is not x divided by x. That is x minus 1 divided by x. I know it's 5x, but I could do that if there was an x here and an x here. But that's x minus 1, meaning if I wanted to eliminate this x, I would have to eliminate an x out of both of these. Okay? So don't do that. It's a real common mistake, and you eliminate the x's and it's negative 1/5. No, it is not. So anyways, do your homework. And by the way, I keep saying anyways. That's just the thing I say. It's not correct. By the way, I'm an English teacher also. It's not anyways, it's anyway. Anyway, do your homework.